Hello, good evening everyone. Can everyone hear me?
Good evening, sir.
Yes, sir.
Good evening. Socrates, can you hear me?
Yes, sir.
Okay. So everyone, we can start. Okay, last day we were doing binomial.
Let us start.
Can you people see my screen? Okay, so everyone, I'll be writing down the answers. Let's see. I had given 16 questions. Okay, let us write down the answers. Number one is 946. Everyone, how much? 946.
Yes, sir.
Okay. Number two is 19C6 minus. What was the answer? I have to check. It's 19C6 minus 6 into 9C6 plus 10C6. Anyone having any doubt? Tell me. Number two, 1, 2. Anyone having any doubt? Number three is 30 and 120. Tell me, Sokrit, Devang, Anandit, Raktim. Anyone having any doubt? Sarthak?
No.
Okay. Number four. Number four. Number four, what is the answer? Number four is 9. Is anyone having any doubt? Number five. Number five is 3094, I guess. What did you people get? 3094. Tell me.
Sir, just let us check this. Yes, sir.
Huh?
3094. 3094.
Yes. Number six, find the number of ways in which we can divide 240.
Sir, can you solve this?
Okay. We need to find out the number of ways of dividing six couples into three groups if each group has exactly one couple and each group has two males and two females. Okay. So six couples should be divided into three groups. Let us mark two groups A and B. So this is number six. Let us mark two groups A and B. Okay. So first of all, there are exactly one couple. Okay. Find the number of ways in which six couples can be divided into three groups. Okay, into three groups. Okay. Okay. So there are three groups, six. Okay. So at first I'm going to select three couples that are going to be into these three groups. So that can be done in how many ways? Number of ways to select three couples for three groups will be equal to 63. Right, tell me. So they have already they are already in the group. Okay, 63. Okay, so over here there are two people. Okay, one male and one female. One male, one female. One male, one female. Right, Socrates, are you getting? This is the number of ways of forming three groups.
Yes, sir.
63. Okay. Next, there should be two males and two females. So there should be two males over here. So I need one more male, one more female over here, one more male, one more female over here, one more male, one more female over here, but they should not be in the same group. Okay. So what I'm going to do is I'll put three males first. Okay. Number of ways. And three males are remaining. Number of ways to put 3 males in these 3 groups. In how many ways can it be done? There are 3 males and there are 3 groups. In how many ways can it be done? Tell me, Sokovic. 63? Sorry, 3 factorial?
3 factorial ways, yes.
Yes. And now 3 females are remaining. Okay. So imagine it like this. Okay. These are envelopes. Okay. Let us say H1 is over here, H2 is over here, H3 is over
We
here.
have to arrange the wives in such a way so that they don't get like next to
Yes.
their. So is it
Husbands.
D3, sir?
Exactly. So number of ways to put 3 females in 3 groups such that they are not they are not they don't form a couple. Form a couple will be equal to D3. So the number of ways
63 into 3 factorial into D3.
63 into 3 factorial into D3. How much it is coming?
Telling me, sir. 2 into 20 into 6. So 240. Sir, can you hear me?
Yes, 240 is correct.
Yes. Sir, can you just allow me for 5 minutes? I'll leave and I'll join from another device.
Okay. Okay, number 7. In an examination, 5 students have been allotted their seats as per their roll numbers. The number of ways in which none of the students, I think D5. It came in J mains D5. Okay, number 8. A1, A2, and A3 are in AP. So over here, we need to find out the value of n. You people got n is equal to 6. Tell me. How much you people got? Raktim, tell me. N equal to 6. Or
So you can
something
solve
else.
this one.
Wait a minute, wait. Oh, there are 3 answers, I guess. N equal to 2, 3, 4. Yes, n equal to 2, 3, 4. Tell me. Sarthak, you have a doubt in this problem?
So yes, I can solve this.
Okay, I'm solving this one. So over here in 1 plus x square whole square into 1 plus x whole to the power n summation of k equal to 0 to n plus 4 ak x to the power k if a1, a2, a3 are in AP. Okay. So over here in this problem, okay, in this problem, okay, what is the right hand side? What is the right hand side? A0 x to the power 0, that is a0 plus a1x plus a2x square plus a3x cube plus dot 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 dot. Right, tell me.
Yes, sir.
Okay. And on the left hand side, what have we got? 1 plus 2x square plus x to the power 4 into 1 plus x whole to the power n. Right. This is equal to
Yes.
this whole thing. So what is A1? Can you tell me? What is A1? Can you tell me?
The x.
A1 is x.
So A1 is 1.
A1 is 1. Coefficient of x is equal to 1 according to you. Right. What is the coefficient of x, everyone? Tell me. I'm getting something else. Why? Tell me. What is the coefficient of x on the left hand side? So I'll make it simpler for you. It will be 1 into 1 plus x whole to the power n plus 2x square into 1 plus x whole to the power n plus x power 4 into 1 plus x whole to the power n. Now tell me, what is the coefficient of x? Tell me, Sarthak. Sarthak, will you get coefficient of x over here?
No, sir.
Why? Why no?
It is coming like integral part of this is like not.
Integral part? Where is the integral part coming from? Because
In the second
Sarthak,
expression, there will be no x, right? The x square is getting multiplied with the inside.
it is already multiplied with 2x square. And this is
Yes.
already multiplied to x to the power 4. So over here only you will get coefficient of x. So what is the
Yes.
coefficient of x over here? Tell me. It's a very simple question.
So
When you
you're discussing
expand
question number 8.
NC1.
NC1, A1 equal to N. Yes, Socrates, I'm
So you're
discussing question.
discussing. Okay,
Yes.
okay.
You have a doubt in 8?
No, no, I just confirmed. I joined back.
Okay. And tell me what is the value of A2? What is the coefficient of x square? What is coefficient of x square on the
NC2 plus 2.
NC2 plus 2? Correct. And what is the coefficient of x cube? NC3 plus
2.
2. So you are going to
So
get
2,
x cube.
so 2 into NC2.
2 into NC1. Right, tell me.
Yes, sir, yes.
Think about it. 2 into NC1. Yes or no? Now
Yes,
see,
sir.
if A1, A2, A3 are in AP, that means 2A2 is equal to A1 plus A3. Right, tell me, Sarthak.
Yes, sir.
Now what is 2A2? 2 into NC2 plus 2 is equal to A1, that is N, plus A3 is NC3 plus 2 NC1. Now we need to simplify this. So it will become 2 into NC2, that will become N into N minus 1 plus 4. This, this will be equal to N plus N into N minus 1 into N minus 2 divided by 6 plus N plus 2N. Right, tell me.
Yes, sir.
After this, we need to simplify. Okay, let us simplify. So multiplying by 6, we'll get 6n square minus 6 plus 24 is equal to n plus 2n 3n, so 18n plus n into 18 plus n cube minus 3n square plus 2n. Right, tell me. Okay, let's
Yes, sir.
simplify. We'll get a cubic. So I'm getting a cubic as n cube. N cube minus 3n square minus 6n square minus 9n square. Okay, plus 2n plus 20n. Oh, 6n square minus 6n. So plus 20n plus 6n, 26n minus 24 is equal to 0. Right, tell me. Sarthak. So Sarthak,
Yes, sir.
can you tell me a good root? Can you tell me a root of this equation? One root of this equation.
2.
2. N minus 2 is a factor.
Yes.
You are capable of factorizing this cubic.
Yes, yes.
Okay. After factorization, you will get n equal to 2, 3, and 4.
Okay, sir.
Is it clear?
Yes, sir.
Okay. Raktim, do you understand? Number 9. Number 9, the answer is option 10. Option D.
Sir, I have a doubt.
So can you tell me one thing that in question number 8, I did the same method, just I factorized it in different way, but still I got two answers. Why? Can you just check my solution once?
Okay, you got the same cubic.
I didn't solve the cubic, sir. I basically that n into n minus 1 is n square minus n. Now I
Mhm.
bought that pn from the other side to this to make it n square minus 4n plus 4. So that becomes n minus 2 whole square equal to n into n minus 1 into n minus 2 by 6. So I cancelled out n. Achha, I cancelled out n minus 2.
Haha. Okay. You
Right.
understood?
Understood. Understood. Understood.
Okay. So while explaining only, you understood where you have gone wrong.
Mhm.
That's good. Okay. Anyone having any doubt with 11? Tell me. Anyone having any doubt with 11? Raktim, Anandit, Devant, Mimel, Sakush, Sarthak. Anyone having any doubt with 11?
No, sir. I think option D is the answer.
Option D is the answer. Hello, Raktim, can you hear me?
Yes, sir.
You have a doubt or should I
No, sir,
proceed?
I have a doubt in 10, sir.
Oh, 10.
Yes, sir. So
Sure.
the summation of coefficient of this.
Okay, okay. The
Sir,
coefficient
not
of
9, sir, 9.
this. Wait a minute. Is number 9 this one? Oh, number 9 I didn't discuss only. Number 9 is option B. Should I
Yes.
start? Okay, should I start? The sum of the coefficients of integral powers of x in the binomial expansion of 1 minus 2 root over x whole to the power 50. Okay, so sum of integral coefficients. This is number
9.
9. What is it? 1 minus 2 root over x whole to the power 50.
Yes, sir.
Okay. Mm, so basically, let us call it s. Okay. Okay, let us expand. So what is s? S is equal to 1 minus 50c1 into 2 root over x plus 50c2. Okay, wait a minute. This is 1 minus 2 root over x whole to the power 50. Okay, so what I've got? 1 minus 50c1 into 2 root over x plus 50c2 into 2 square, that is 4 into x plus dot 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 minus dot 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 dot. So basically we need the even powers. I mean 50c2, 1, all these things we require, right? Tell me,
Yes, sir.
Raktim?
Yes, sir.
Then we require 50c4, means all these terms should get cancelled. What I'm going to do is I'm going to write 1 plus 2 root over x whole to the power 50, and then I'm going to add 1 plus 50c1 into 2 root over x so that all the irrational powers gets cancelled.
Sir, now I understood. Now I solved the remaining.
Rest of the sums, I think you can solve it.
Yes,
Okay?
sir. Now I understood.
Okay. So I'm leaving this for you. Let us move on to question number 10. 10 is option A. Anyone having any doubt? Tell me.
No, sir.
11 is D, I have already told. Number 12 is n equal to 7 and 14. Anyone having any doubt, you can ask me. Number 13 is a proof problem. Anyone having any
Can I
doubt?
solve this, sir?
Okay, let us solve. It is given summation of r equal to 0, ar into x minus 2 whole to the power r equal to summation of r equal to 0 to 2n dr into x minus 3 whole to the power r. Okay, let us start. This is number 12. So let us expand. Okay, what are we getting? we are going to get a0.
So number 13, I think.
I think. Okay. a0 into x minus 2 whole to the power 0 plus a1 into x minus 2 whole to the power 1 plus a2 into x minus 2 whole square plus dot 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 dot. What do we need to find out? We need to find out b. We need to find out bn, right? Okay, nth term. So everywhere I need to define the nth term plus dot 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 plus an x minus 2 whole to the power n plus an plus 1 x minus 2 whole to the power n plus 1 plus dot 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 plus a2n x minus 2 whole to the power 2n. This will be equal to b1, sorry, b0 plus b1 x minus 2 whole to the power plus b2, sorry, x minus 3 it is, plus b2 x minus 3 whole square plus dot 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 plus bn x minus 3 whole to the power n. Okay, plus dot 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 goes on like this. Tell me, are you getting suffering up to this much?
So, sir, see here, just asking you that is it like a0 is the coefficient of x minus 2 to the power 0? So, can I say that this is like in the expansion of 1 plus x minus 2 whole to the power 2n, a0, a1, a2 will be the binomial coefficients?
Couldn't understand. Go slowly
Like,
a little bit.
like
Tell me.
in the expansion of 1 plus x minus 2 whole to the power 2n.
1
Okay.
plus x. Hmm.
In there, a0, a1, a2 will be the binomial coefficients.
I understood. Yes. Go on.
So, is that how we are going to solve, or we are going to use something else?
We are going to compare
Achha. Okay.
because over here a0, a1, a2, all these things are not defined. Are you getting?
Yes, sir.
Okay. So I'm going to compare over here. Okay. What do I need? I need the coefficient. I need bn. Okay. Mm, I need bn. Okay. So what I'm going to do is put x minus 3 is equal to t. Okay. So if x minus 3 is equal to t, this will become a0 into x plus 1 plus a1 into x plus 1. Sorry, t plus 1 plus a2 into t plus 1 whole square plus dot 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 plus an into t plus 1 and so on. Right, just check. This will be equal to b0 plus b1t plus b2t square plus dot 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 plus bn t to the power n plus n and so on. Okay. Now we need to compare the coefficients of t to the power n. Okay, what is the coefficient of t to the power n? Coefficient of t to the power n will be equal to bn on the right hand side. Tell me,
Yes, sir.
what is the coefficient of t to the power n on the left hand side? This will be equal to how much?
Sir, an.
Wait.
I think
Not
that's
a.
yes, n.
Ah, that's so only n. I don't think so. What is the coefficient of t to the power n on both sides? Wait, let me check. On the right hand side, t plus 1. Only over here we'll get t to the power n or somewhere else also. Wait, let
Yes,
me
shouldn't
just
be
write
t
down.
plus 1 to the power 2n.
Wait. T plus 1 whole to the power n plus 1 plus dot 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 dot. Over here also we'll get t to the power n plus dot 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 a 2n p plus 1 whole to the power 2n. Okay. Now over here, coefficient of, I mean, over here, this is the first time we are going to get t to the power n, right?
Hmm.
Tell me. So what is the coefficient of t to the power n?
For the first, it's for the first term, it is simply an.
an
For the second term, sir, it will be an plus one. You've written just an. See.
an plus 1,
So here the coefficient should be an plus one only.
an plus 1.
So an plus one up to a2n.
Yes. Okay.
Hmm.
And all of them are 1. You can understand because in the question it is given that ak is equal to 1. Just check. The question it is given ak is equal to 1 for all k greater than or equal to n. So after that, an plus 1, an plus 2, all of them will become 1 only. Are you getting?
So simply n.
So it will become nc0 plus n plus
NC0,
1
sir.
c.
We are adding the coefficients, right? So it should be n.
Hmm? I'm
Achha,
adding
coefficient. Understood.
n plus 1 c0, n plus 1 c1 plus n plus 2 c2 plus dot plus 2 ncn. Tell me, is it clear?
Yes, sir.
Okay. Now, do you remember how do we used to add this series? Instead of nc0, can I write it as n plus 1 c0? Can you understand?
Yes, sir.
Now, what is ncr plus ncr plus 1? N plus 1 cr plus 1. So it will become n plus 2 c1 plus n plus 2 c2 plus dot plus 2 ncn. Tell me.
Sir, I think the second term will be n. N plus one c1 above and n c1 below. Or what?
Couldn't understand.
How do you write the second term?
This
I
one.
mean, hmm, hmm, hmm.
Okay, over here, I need the coefficient of,
No, I'm not asking that, sir. In the next step, when you change nc0 to n plus 1 c0,
uh,
then how do you write n plus 1 c1? Achha, you didn't change only that term. Understood. You just change the first term, right? So that
I
you get
change
n plus 2 c1.
so that I get ncr plus ncr plus 1 form. Okay.
Understood.
Now, next one will become n plus 2 c2. Okay, n plus 2 c1 plus n plus 2 c2. ncr plus ncr plus 1 will become n plus 3 c2 plus n plus 3 c3. Are you getting? After n iterations, you are going to get 2ncn minus 1 plus 2ncn. Okay, this will give us 2ncn plus 1. Hence proved. Tell me, is it clear, Socrates?
Yes, sir. Yeah.
Okay. There is another method. What you could have done was, if all AIs are equal to 1 for I greater than or equal to n, then from here to here, you have got a GP series? Yes or no? From here to here, you have got a GP series.
Yes, sir.
You can solve the GP series. Okay, then also you'll get the answer. Tell me, should I do it by that method also? Or
No,
this
I
will...
tried very nicely.
Okay. Is it clear to others? Tell me. Others have understood? Raktim, Anandit, Devang, Nemel, Sarthok. Do the people understand?
Yes, sir.
Yes.
Okay. Number 14. Number 14 is option B. 15 is 1 by 8. 16 is 1,002 C 500. Tell me. Devang, Raktim, Anandit, Nemel, Socrates, Sarthok. Anything else? Tell me. Socrates, anything
No,
else?
sir.
Tell me.
No, sir.
Perfect. So last day, what were we doing? The last day, this was the last problem we had done, right? Okay. Anyone having any doubt from the last class? Tell me. You people have understood this problem, right? Tell me. Number 8, everyone has understood, right? Tell me, Sarthak, did you understand? Anandit,
Yes, sir.
Rakti?
Yes, sir.
Okay. If you people have understood, let us move on. Let us do some more problems. Okay. Okay. Question number 1 and 2 for today. Okay. Quickly solve, everyone. Then we'll move on. Question number 1. Question number 2. Solve. Then let me start, everyone. Number 1.
Sir, please wait.
Yes, sir.
Okay. Send. Others also solve. Rakti, Anandit, Sarthak, solve quickly. Rectum number 1 is correct. Devang, number 2 is correct. Safrit, number 1 is correct. Okay. Sarthak, Memel, Devang.
So we must start number 1.
Yes, Anandit, I'm solving number 1. Pay attention. So what you do is you write down the series once. Just open the summation and write down the series. Can I write it as NC0 sine 0x cos nx plus NC1 sine x cos n minus 1 whole x plus dot 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 dot. Okay. Plus NCN, whatever you will get. Okay. Then what you do is let us call it S. Let us write down S once again. Okay. But in the reverse order now. Okay. So NCN sine nx cos 0x plus NC1 sine n minus 1 whole x into cos x plus dot 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 dot. This will be equal to S. So after this you add. On adding, NC0 and NCN, they are same only. Right? Memel, Sarthak, Anandit, Devang,
Yes,
are you
sir.
people getting?
Yes.
NC1 and NC, sorry, this will be NCN minus 1. They are same only. Right? So what are you getting? You are going to get NC0. Now, what is sine 0x cos nx? Sine nx cos 0x. When you add, so it will be sine nx only plus NC1 into sine nx plus NC2 into sine nx. Are you getting? Sarthak plus dot 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 plus NCN into sine nx. This will be equal to 2s. So what is 2s? 2s will be equal to sine nx common NC0 plus NC1 plus up to NCN. Okay. This will be equal to sine nx into 2 to the power n. So now you divide it by n. You are going to get the result 2 to the power n divided by 2 into sine nx. Hence proved. Tell me, is it clear? 2 to the power n minus 1 into sine nx. Hence proved. Tell me. Sarthak, is it clear? Bhakti?
Yes.
Okay. Anandit, is it clear? Anandit, Devang,
Yes, sir.
Memel, have you understood?
Yes, sir.
Yes, sir.
Okay. Sarthak, second one is correct. Memel, second one is correct. Okay, for second one, who is left? I think Socrates is left. Socrates, should I start? Number 2,
Sending you the answer.
then Socrates is left. Okay. Yes, Socrates, your answer is correct. So who is left? Rakti is left. And Anandit is left. So Rakti and Anandit, should I start? Second one?
Sir, can just give me 1 minute? I'm writing the answer.
Right. Okay, Raktim, this can be further simplified. Simplify it quickly. Yes, Anandit, right. Anandit, right answer. Okay, Raktim, I'm starting. We need to find out the sum of the
Sir, I'm simplifying, sir. 1 minute.
simplifying. Simplify quickly. Then we'll move on.
So even sir, 2 to the power 19 minus 19 second.
No. Okay, I'm solving. We need to find out the sum of the last 10 coefficients. Okay. What is the sum of the last 10 coefficients? From where will it start? From where will it start? Number 2. It will be 19C. Wait a minute. It will be 19C10 plus 19C9 plus 19C8. Sorry, 19C11 plus 19C12 plus dot up to 19C19. Right, tell me.
Yes, sir.
Okay. Next, this 19C10, can I also write it as 19C9 plus 19C8 plus 19C7 plus up to 19C0? Tell me. This is also S. This is also S.
Yes,
Adding,
sir. 2.19 makes sense.
will get 2 to the power 19. So S is equal to 2 to the power 19 by 2. That is 2 to the power 18. Done. Next, let us do some more problems. Okay, quickly solve. This is question number 3, 4, and 5. Okay, question number 3, 4, and 5. Solve. Yes, everyone, should I start with 3?
I've sent you, sir.
Oh, yes. Sophie has sent it. Your answer is correct. So, everyone, should I start? Pratim, Anandit, Devang. Okay, let us see. Over here, what you do is you take half common. So, when you take half common, what are you getting? You are going to get C0 minus 10C1 into 2 plus 10C2 into 2 square minus 10C3 into 2 cubed. Are you people able to get any pattern? Tell me.
Expansion of 1 minus x to the power n.
Exactly. Are you people able to identify? Yes or no?
Yes.
Okay. This is expansion of 1 minus 2 whole to the power 10. Right? Memel, are you getting?
Yes, sir.
This will be equal to half. Done. Okay, quickly solve 4 and 5. Tell me, Sathik, did you understand the previous one?
Yes, sir.
Okay. Rakti Manandit, please.
Yes, sir.
Oh, quickly solve number 4. 4 is very easy. Number 4 is very easy. A similar kind of summation, I had done it just now. Yes.
Not
So,
similar, exactly same.
yes. I have to remind, I didn't want to be exact. Yes. Sakrohit, your answer is correct. Tell me, should I start, everyone?
Sir, 1 minute, sir. Sir.
Yes, Raktim, your answer is correct. Okay. So I think you people have forgotten. Sathok,
Para sending.
yes. Send. Quickly send. Yes, Devang, right answer. Okay. Anandit, Mimel, Sarthak, pay attention. Okay, just now I have done this summation, right? Just now. N plus 1 C0, N plus 1 C1, similar kind of summation. I've done it, right? Yes. Okay, wait. Mimel, can you hear me?
Yes, sir.
Okay, how is that one possible? Like N plus 1 C0 plus N plus. I mean, you wrote something, right? I just have a question. You wrote N plus 1 C0 plus N plus 1 C1 is equal to N plus 2 C1. Right, you wrote this, see?
Yes, sir.
So according to you, NCR plus NCR plus 1 is equal to N plus 1 CR plus 1, right? Tell me.
Yes, sir.
But over here, this NC0 you wrote N plus 1 C0. How? Tell me. Are the values NC0 and N plus 1 0 same? Tell me.
Yes, sir.
What is the value of N plus 1 C0? Tell me.
Sir, NC0 to is 1.
And what is N plus 1 C0?
Sir, it is also 1 according to identity.
Okay, okay. Then it's fine. Okay. So yes, this is the method and this is the correct method. Everyone pay attention. Okay. It was given NC0 plus N plus 1 C1 plus N plus 2 C2. We need to prove that this is equal to plus N plus R CR. We need to prove that this is N plus R plus 1 CR plus 1. Okay. N plus R plus 1 CR. So over here, instead of NC0, if I convert it into N plus 1 C0, okay, it is still okay. Tell me, Sarthak, Anandit, are you people getting?
Yes.
Okay. Now, what is NC0 plus NC1? Tell me. What is NCR plus NCR plus 1? N plus 1 CR plus 1? So it will become
Yes.
N plus 2 C1 plus N plus 2 C2 plus up to N plus R CR. Okay. Now, N plus 2 C1 plus N plus 2 C2 will become N
Plus
plus 3
3 second.
C2. Okay. Plus dot 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 plus N plus R CR. After R steps, what are you getting?
N
N
plus R
plus
plus 1
R
CR.
CR minus 1 plus N plus R CR. This will be equal to N plus R plus 1 CR. Is it clear? Hence proved. Tell me, Anandit, is it clear?
Yes, sir.
Quickly solve number
And also
5.
the last step.
Yes,
Okay,
what?
it is R plus 1. Yes, yes. Okay, okay.
Yes. Quickly solve number 5. Okay, should I start with number 5? Tell me, everyone.
So just give 2 more minutes.
2 more minutes. Quickly solve. Yes, Swapnit, your answer is correct. Okay, let us start, everyone. Okay, we need to find out this determinant. Everyone pay attention. What is summation of k equal to 0 to n? K. Tell me. What is the first element of the determinant? Summation of k equal to 0 to m. K
n into n plus 1 by 2.
n into n plus 1 by 2. Right, tell me. Dr. Sarthak, are you getting? Yes or no?
Yes, sir.
And what is summation of k equal to 0? Everyone pay attention. Summation of k equal to 0 to n nck into k square. What is the first term? First term is
NC is 0 only. First term is 0.
0. What is the second term? Second term
NC1
will be
T1 1 square.
nc1 into 1 square plus nc2 into 2 square. Okay, and so on. Okay, but let us not solve it like this. Basically, it is summation of k square into nck. Okay, from k equal to 0 to n. Can I write it as summation of k equal to 0 to n, k into nck? Okay. Now, what is summation of k into nck? This we have already done it before, if you remember.
Sir, n into 2 to the power n minus 1.
Summation of k equal to 0 to n. This will be n into 2 to the power n minus 1.
Yes, sir.
And this is multiplied by k.
Okay, yes, sir.
Okay. So n into 2 to the power n minus 1 comes outside. This will be n into 2 to the power n minus 1. Summation of k equal to 0 to n. And this will become summation of k. So it
So
is n
finally
into
you're
n.
getting, yes, sir, n into n plus 1 into 2 to the power n minus 2.
Wait a minute. This is n into n plus 1 by 2. Why is it
And then
coming?
multiplied with n to the n into 2 to the power n minus 1.
Wait. This one we have already done it before. Okay, summation of k square into nck. Okay, so everyone pay attention. We have already done summation of k square into nck. Wait, where is it? And summation of k into nck, we have done it. Pay attention. That is n into 2 to the power n minus 1. Okay. Summation of k square into nck we didn't do. Okay. Anyways, let us write it. So it is n into 2 to the power n minus 1. This will become n into 2 to the power n minus 1 into summation of k equal to 0 to n k. So this will become n into 2 to the power n minus 1 into n into n plus 1 by 2.
Sir, here k is starting from 0, right? So 0 plus, sorry, the value will be same.
Yes. But why it is coming square now? That's what I'm concerned about.
Like in my solution, I'm now realizing I've missed one n. I should have got that square.
Summation of k square into nck, I have not done it. Wait. n into 2 to the power n minus 1, it will come outside. Okay, I think it should be n square only. So it is n square into n plus 1 by 2. Let's see. n square into n plus 1 by 2. But it is the whole summation. Okay, when we take summation over the whole thing, this is I mean, this is where the mistake lies. Okay, you cannot take summation separately. Okay, you have to simplify this first, k into nck. Are you getting? Don't take summation separately. This is where I was making the mistake. Wait. So k into nck will be what? K into n by k into n minus 1 ck minus 1. Right. So k gets cancelled. You are getting n into n minus 1 ck minus 1. So you are going to get summation of k equal to 0 to n. Okay, n will come outside. It will be k into n minus 1 ck minus 1. Okay. Again, this one we can simplify. Okay. So k into n minus 1 whole factorial divided by k minus 1 whole factorial. Okay. Into n minus k whole factorial. Okay. Again. Okay. So this one we can multiply and divide by n. K into n minus 1 ck minus 1. Wait a minute. Wait. Don't speak up in between. Summation of k. This is k minus 1 whole factorial, no? Okay, wait. Summation of k divided by n over here n factorial divided by then it will become k square only. So what's the use? No. I have to think of something else. Wait. So that k gets removed. It will not be done like this. Yes. I have to think in some other way. So wait. If this summation is not coming like this, okay, what we can do is, okay, pay attention. Summation of k square into nck. Okay. It is not coming like this. I think I have to differentiate it twice then. Yeah, I think I have to differentiate it twice. Just let me think. I'll solve. Okay, let us try it once more. Okay. Summation of k equal to 0. Summation of k equal to 0. Okay, I got it. Summation of k equal to 0 to n. K into nck. Okay, everyone. So over here, k into nck, I can write it as k by n. K into n by k into n minus 1 ck minus 1. Tell me, are you people getting? So this will become
Yes.
n into n minus 1 ck minus 1. Okay. So this will become summation of k equal to 0 to n. N will be outside. K into k into n minus 1 ck minus 1. We got it up to this much last time also. Okay. Next, now what I'm going to do is I'm going to bring it in this form only, k into nck, by subtracting and adding 1. Are you people getting? So n into summation of k equal to 0 to n k minus 1 plus 1. Okay, into n minus 1 ck minus 1. Tell me, are you people getting? Yes or no? So this will become n into summation of k equal to 0 to n k minus 1 into k n minus 1 ck minus 1 n minus 1 ck minus 1 plus summation of k equal to 0 to n minus 1 ck minus 1. Tell me, Sarthak, Sakrit, Devang, Anandit, Raktim, Memel, are you people getting? Tell me, did you people understand up to
Yes.
this much? Yes or no?
Yes, sir.
This
Yes.
this is also multiplied by n, because if n is multiplied outside, n should be multiplied over here also. Okay. Now let us simplify. Okay. So this will become summation of k minus 1. So again n minus 1 will be outside. So it will become n into summation of k equal to 0 to n k minus 1 into n minus 1 by k minus 1 into n minus 2 c k minus 2. Okay. K minus 1 will get cancelled. N minus 1 will be outside. So now I'm getting n into n minus 1 into summation of k equal to 0 to n minus 2 ck minus 2. Tell me, are you people getting? Plus n into summation of k equal to 1, k equal to 0 to n minus 1 ck minus 1. Okay. Now I'm going to simplify. This will become, so this is the sum of all the binomial coefficients except, no, I think, no, this is the sum of the binomial coefficients. So it will be n into n minus 1 into 2 to the power n minus 2. For k equal to 0 and 1, the terms are not defined. And over here also for k equal to 0, the term is not defined. Okay. So I'm not going to write it. So it will become n into 2 to the power n minus 1. Okay. Now you take common 2 to the power n minus 2. N into 2 to the power n minus 2 is common. Within brackets, you are going to get n minus 1, n minus 1, 2 to the power n minus 2, add to common, so plus 2. So it will become n minus 1 plus 2. This will become n into n plus 1 into 2 to the power n minus 2. This is what you are going to get. Tell me, are you people getting? Yes or no? If there's anyone who didn't understand this summation, you can ask me. Tell me.
But sir, one thing, when you are like writing case
One minute. Yes, tell me, Socrates. Now tell me.
that when you are writing k square into nck as k into k nck, why can't you take the summation inside it, taking like separating out k?
Why
Where
don't
will we
you
have the problem?
why don't you understand that k is a variable? It is not a constant over here. You can't take the summation this on separately and this on separately. It's not possible.
Yes, 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 yes,
Are you getting my point? They both
yes,
are
sir.
variables. Had it been this is a constant, then it's okay. Then it's not a problem. Okay. The problem arises when both are variables. We cannot take the summation over here separately. That is where I was making a mistake in the previous uh, approach. Understood, Socrates now.
Yes, sir.
Others have understood. Raktim, Anandit, Sarthak, Memel, did you people understand?
Yes.
Devank, did
Yes,
you
sir.
understand? Tell me. If there's any step you couldn't understand, you can ask me. I'll explain again. Tell me. Any step you couldn't understand, I'll explain again. Tell me. Socrates, Sarthak, is it clear?
Yes, sir.
Okay. Okay. So basically, this will not become n square. Remember. Okay. So the whole determinant will become, I mean, now it will become n into n plus 1 into 2 to the power n minus 2. Yes. Now it's fine. Okay. Third one. What is the third one? Summation of k into nck. This we have already done it just now, right? So it is n into 2 to the power n minus 1, right, everyone? Tell me. The third one will become n into 2 to the power n minus 1. And what is the fourth element? Tell me. What will be the fourth element? nck into 3 to the power k. Tell me. nck into 3 to the power k. This will be equal to nc0 into 3 to the power 0 plus nc1 into 3 to the power 1 plus nc2 into 3 square. Is it looking familiar? Tell me. Are you people able to relate it with something? Tell me. Is this looking familiar?
Sir, 1 plus 2.
1 plus 3 over to the power n.
Sir.
So this will become 4 to the power n. So this is what the determinant looks like. Now I'm going to simplify the determinant. Okay. Okay. Let us simplify. Okay. Let us cross multiply, everyone. On cross multiplication, we are going to get n into n plus 1 by 2 into 4 to the power n minus n into n plus 1 by n into n plus 1 into 2 to the power n minus 2 into n into 2 to the power n minus 1. Okay, let us simplify, everyone. This is going to come as, we can take 2 as LCM. Okay, numerator would be n into n plus 1 into 4 to the power n minus n into n plus 1 into 2 to the power n minus 2 into 2 to the power n minus 1. So it will come as 2 to the power n minus 1 plus n minus 1. So 2 to the power 2n minus 2. Let me check. Achha, wait. Okay, forget about it. What do I need to find out? I need to find out the value of n, right? So 2 to the power 2n minus 2. Okay, this is equal to 0. Now, since n cannot be equal to 0, I can cancel out this. I can cancel out this also. So I'm getting 4 to the power n minus 2 to the power n minus 2n minus 2 is equal to 0. So taking 4 to the power n minus 1 common, we are going to get 4 minus 4 minus 8. 4 minus, somewhere I'm making a mistake. There should be one more factor. Oh yes, I'm missing out one factor. Yes, it should be n over here. Okay, so 4 minus n, this will be equal to 0. So n is equal to 4. Tell me, is it clear to everyone, or should I explain again? Tell me, Sakrit, Devang, and Anandit, Raktim, Nemel, is it clear?
Yes, yes.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so everyone, we can continue. Okay, it's a good problem. This kind of questions you can expect in mains. Okay, let us continue. Our next topic is binomial theorem. Binomial theorem. For n belongs to rational numbers. Okay, when, and this only is valid, rational numbers, this is only valid when mod of x is less than 1. Okay, otherwise it is not valid. Okay, like I'll give you some example. You see, do you people remember this summation 1 plus x square plus x cube? If I take this infinite sum, when do you think it is valid? Tell me. If I take the infinite sum, when it is valid? Okay, first of all, tell me what is the summation? 1 plus x square plus x cube plus up to infinity. What is the sum?
1 by 1 minus x.
1 by 1 minus x, right? Which can be written as 1 minus x whole to the power minus 1. Are you people getting? And when is it valid? Tell me.
Sir, x is lesser than 1.
When mod of x is less than 1, right? Tell me. Okay. Similarly, you can find out other summations also. Okay. So everyone, there is some basic expansion. That is 1 plus x whole to the power n. This will be equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cubed plus up to infinity. Okay. Number 2. 1 plus x whole to the power minus n. All these expansions are valid only when mod of x is less than 1. Then only the series will converge. It will be 1 minus nx plus n into n plus 1 by 2 factorial into x square minus n into n plus 1 into n plus 2 by 3 factorial into x cube plus dot 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 up to infinity. Okay, try to understand everyone. When we substitute minus n over here, then we are going to get the second expansion. Next, number 3. If I want to find out 1 minus x whole to the power n, what to do? How do we find out 1 minus x whole to the power n? By putting, let us call this equation 1, let us call this equation 2. By putting minus x in place of x in equation 1. So let us substitute. What are we getting? 1 minus x whole to the power n. This will be equal to 1 minus nx plus n into n plus 1. Sorry, plus n into n minus 1 by 2 factorial into x square minus n into n minus 1 into n minus 2 by 3 factorial into x cube dot 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 up to infinity. Similarly, for 1 minus x whole to the power minus n, what do we need to do? In the third equation, we need to replace n by minus n. And this fourth binomial, fourth expansion is very, very, very important. Okay. You see PYQs, you will understand. A lot of questions have come. Okay, based on 1 minus x whole to the power minus n. So this will be equal to 1 minus 1 plus nx plus n into n plus 1 by 2 factorial into x square plus n into n plus 1 into n plus 2 by 3 factorial into x cube dot 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 dot. And if I ask you, what is the coefficient of x to the power r in the last one? What is the coefficient of x to the power r in 1 minus x whole to the power minus n? Can anyone tell me?
N into n plus 1 into n plus 2 up to n plus r minus 1 by r factorial.
Exactly. Up to n plus r minus 1 by r factorial. Okay. Now see, this is a huge expression. Let us convert it into a simpler one. What I'm going to do is I'm going to multiply by n minus 1 whole factorial. Okay. Let us convert n minus 1 whole factorial. I'm going to multiply by n minus 1 whole factorial in the numerator and in the denominator also. Okay. Let us write. Are you people getting yes or no? Raktim, Anandit, Devang, Sokrit, Sarthok, Nemil,
Yes.
are you getting?
Yes.
So this will become n plus r minus 1 whole factorial. Sorry, this will become n plus r minus 1 CR. Tell me, are you people getting? So coefficient of x to the power r in 1 minus x whole to the power minus n will be equal to n plus r minus 1 CR. Tell me, is it clear, Raktim?
Yes, sir.
Okay. Socrates, have you understood?
Yes, sir. So can you solve the series at once?
Yes. These series are very important, especially the last one. Last one is highly important.
Done, sir.
Done. Okay. So I'm posting more questions. Okay. Quickly solve. 6, 7, 8, 9. Okay, quickly solve. Is Socrates the right answer? The Sarthak number 7 is correct. Socrates 6 is correct. Okay. Program, should I start with 6? Tell me.
Sir, please wait. Almost done.
Okay. Is Devang right answer? Okay, so Raktim, Anandit, Memel, and Sarthak, pay attention. You need to find out the range of x for which 8 plus x whole to the power 4 by 3 is valid. What you do is, you compare it with 1 plus x whole to the power n. Okay. Okay. But over here we have 8. So what you do is you take 8 common. When you take 8 common, you are going to get 8 to the power 4 by 3 into 1 plus x by 8 whole to the power 4 by 3. Okay. So this expansion is valid when mod of x by 8 is less than 1. This implies x should belong to minus 8 comma 8. Are you getting? Tell me. Sarthak, Anandit,
Yes, sir.
Raktim, Memel, did you understand number 6?
Yes, sir.
Yes, Memel, number 7 is correct. Quickly, everyone solve number 7. Anandit, did you understand 6?
Yes, sir.
Yes, Socrates, number 7 is correct. Memel, number 9 is correct. Okay. I'm starting with number 7. We need to find out the 8th term in the expansion of 1 plus 2x whole to the power minus 8. So what is the 8th term? Okay. T8 will be equal to T7 plus 1. Okay. This will be equal to minus 8 into minus 9 into minus 10 up to minus 14. Okay. Multiplied by 2x whole to the power 7 divided by 7 factorial. So multiplying by 7 factorial in the numerator and denominator, we are going to get 14 factorial divided by 7 factorial into 7 factorial into 2x whole to the power 7. And the whole thing will be negative. This will be equal to minus 14c7 into 2x whole to the power 7. 10. Is it clear, Raktim? Anandit?
Yes, sir.
Okay. Devant, did you understand? Devant, you have simplified it or what?
Yes, sir.
But wait a minute. Devant, I think you are making some mistake. You have written 4 plus 7 minus 1, right?
Yes, sir.
You're making a mistake. See, over here, the expression is 1 plus 2x whole to the power minus n. It's not 1 minus x whole to the power minus n.
Oh,
Are you getting?
yes, sir. Understood.
Okay.
Sir, is number 8 correct?
No, check number 8. Socrates number 8 is correct. Socrates number 8 is correct. Okay. So let's start with 8, everyone. We need to find out the coefficient of x power 100 in 3 minus 5x into 1 minus x whole to the power minus 2. Okay, let
Sir,
me check
1
your
minute,
answer.
send it.
Send quickly. Satvik, check number 8. Anandit, there is a slight mistake. Yes, now it is correct, Anandit.
Sir, 1 minute, send it.
Send quickly, sir. Yes, Socrates 9 is correct. Okay, I'm starting with 8. We need to find out the coefficient of x power 100 in 3 minus 5x into 1 minus x whole to the power minus 2. Okay, so number 8. Pay attention. So over here, 3 minus 5x into 1 minus x whole to the power minus 2. This can be written as 3 into 1 minus x whole to the power minus 2 minus 5x into 1 minus x whole to the power minus 2. Okay. So over here, what is the coefficient of x to the power 100? Coefficient of x to the power 100 will be, in the first term, it will be 3 into 2 plus 100 minus 1, C2, n plus r minus 1, CR, sorry, 100.
C100, sir.
Yes, I wrote it. Minus 5 into, over here, we need the coefficient of x to the power 99. Are you people getting? In the second expression, we need the coefficient of x to the power 99. Yes or no?
Yes, sir.
Okay. So quickly tell me, Sarthak, what is the coefficient of x to the power 99?
Sir, 100.
100. Wow. How? Tell me. Don't you think it will be 2
Sir,
plus
n
100?
plus r minus 1.
Oh, you got it 100 like this.
Yes, sir.
Okay. So you should have written 2 plus 99 minus 1 upon C99, right?
Yes, sir.
Okay. Actually, it should be 5 into 100. Okay, next. So over here, we are getting 3 into 101 minus 5 into 100. That will give us 303 minus 500, which is equal to minus 197. Is it clear, Sarthak?
Yes, sir.
Okay. Ratim, is it clear? Okay. Devang, have you understood?
Yes, sir.
Okay. And Mimel, have you understood? Tell me.
Yes, sir.
So I'm starting with number 9. Find the terms independent of x in the expansion of 1 minus x whole square into 1 plus x. So it is 1 minus x whole square into 1 plus x whole to the power minus 2. So term independent of x is the first term only when 1 is multiplied to 1. Otherwise, all are carrying x. So term independent of x will be equal to 1 into 1, which is 1. Is it clear, everyone? Tell me. Hello, has everyone understood?
Yes, sir.
Okay, next. Our next topic is very important, highly important topic. Okay, if you can understand this topic correctly, you'll be able to solve problems within, I mean, in a more concrete way. Okay, generating functions. So everyone pay attention, generating functions. So basically, what are generating functions? Let AR be equal to, let AR be a sequence, A0, A1, A2, dot, up to AR, okay, dot, it goes on up to infinity. Be an infinite sequence. Be an infinite sequence of numbers. Be an infinite sequence of numbers. And the generating function of the sequence, then the generating function of the sequence AR is defined as, is defined as the polynomial of infinite degree at infinite degree. Ax is equal to summation of r equal to 0 to infinity ar x to the power r. Okay. So everyone, when we expand, what are we getting? 0 plus a1x plus a2x square plus dot 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 up to infinity. Okay. And how will this help us in binomial or PNC? Pay attention. Application of generating functions. Application of generating functions. Pay attention. So for large number of selections, okay, whenever I want to calculate large number of selections, okay, pay attention. For large number of selections, of selections of objects, of selections of objects, we use generating functions. We use generating functions. Okay. Here we group. Here what do? We group alike objects together. We group alike objects together. And with each group, we define a variable. With each group, we define a variable. Okay. Representing the number of objects. Representing the number of objects that can be selected. Representing the number of objects that can be selected from the group. That can be selected from the group. From the group. And then we add all the variables. Then we add all the variables. All the variables. Okay. And get the sum total. Get the sum total of objects that need to be selected. Okay, I'll give you an example. It will be more clear. You'll understand. Objects that needs to be selected. Okay. So everyone pay attention. For example, okay, an illustration. Okay, pay attention. Okay, some of the numbers on throwing 2 dices. Okay, some of the numbers. On throwing 2 dices. On throwing 2 dices. Okay. Pay attention. Okay. So whenever we roll a dice, when we roll a dice, what are the outcomes? Tell me, everyone. Anyone tell me?
1 to 6.
1 to 6. 1, 2, 3, 4, 5, 6. Now I'm rolling a dice, so I'm taking a function. Okay, everyone. Let f of x, I'm taking a polynomial. F of x will be equal to x plus x square plus x cube plus x power 4 plus x power 5 plus x power 6. Okay, I'm taking a function multiplied by this whole thing. Now, why I have taken this? Okay, you will understand in some time. Okay. So when you multiply, everyone, when you multiply these two expressions, what are you getting? You are going to get x square plus x cube plus x power 4 plus x power 5 plus x power 6. Then you are going to get x cube plus x power 7 also plus x to the power 4 plus x power 5 plus x power 6 plus x power 7 plus x power 8. Then we are going to get x power 4 plus x power 5 plus x power 6 plus x power 7 plus x power 8 plus x power 9. Then we are going to get x power 5 plus x power 6 plus x power 7 plus x power 8 plus x power 9 plus x power 10. Then we are going to get x power 6 plus x power 7 plus x power 8 plus x power 9 plus x power 10 plus x power 11. Okay. Then we are going to get the same thing. Okay. Then we are going to get the same thing with x power 12 also. Okay. Right, everyone? These are the terms we are going to get without adding. Right. These are the terms we are going to get. Okay, you people tell me, how many terms are there without addition? We are not adding. Without addition, how many terms are there?
36.
36, right, Sarthak?
Yes.
And Sarthak, what is the total number of outcomes when you roll two dices? Whenever we roll two
36.
dice, 36 only. Right, tell me. Nemel, Devant, Anandit, Raktim,
Yes,
are you people able to understand?
Yes, sir.
Yes, sir.
Sakrit, are you getting?
Yes, sir.
Why did I take this polynomial only? What is the reason behind it? Okay. Now, at the first instance, how will you think about this polynomial? Okay, that also I'll explain. Okay. Next, over here, over here, can you people tell me what is the, you can see that the coefficient of, you can see that the coefficient of x to the power 4 is equal to, what is the coefficient of x to the power 4? Tell me,
3.
3. Okay. And can you people tell me, and we can get the sum also equal to 4 in how many ways? When you roll two dice, also in three ways, right? Tell me, what are the ways
1,
in which you
3,
can
3,
get
1, 2, 2.
1, 3, 3, 1, 2, 2, right? Are you people able to relate? Tell me, yes or no? You are going to get x to the power 4 when you multiply, 1, 3, 3, 1, and 2, 2, right? Sarthak, are you getting?
Yes, sir.
Okay. Raktim, Anandit, got this?
Yes, sir.
Yes, sir.
Sakrit, have you understood? Tell me.
Yes, sir.
Nemel, Devant, is it clear?
yes, sir.
Okay. So now, at the first instance, how will you think about the how will you think about the polynomial only? Okay. So note it down. You see, there are two dices, right? Think of the two dices as a shop. Okay. So everyone, what are the outcomes that you can get when you roll the first dice? Either you will get one, or you'll get two, or you'll get three, or you'll get four, or you'll get five, or you'll get six, right? And since both the events are happening simultaneously, I mean, you're rolling two dice simultaneously, okay, again, you'll get either one, or two, or three, or four, or five, or six. Are you people getting how to think about the polynomial whenever in a particular experiment? Tell me.
Yes, sir.
I'll give some more example. You'll understand.
So can I
Tell
ask
me.
something?
Yes, tell me.
Sir, say instead of two coins, the combination is tossing a coin and rolling a dice. So will it be x plus x square into this expression? X1 up to x6.
It depends upon what you're assigning to. If you're assigning one to heads and two to tails, then you can write x plus
Yes,
x
one to hit.
square.
Acha, acha, acha. Okay.
Yes. Basically, it depends upon the number of selections. Okay. I mean, this is more useful in case of number of selections. Okay. I'll give you some more instances. Okay. And I'll give you some more examples also. So, do you people remember we did beggars method where we were distributing three coins to how many beggars? Sorry, 10 coins to three beggars, right? Do you remember? B1 plus B2 plus B3 equal to how much? 10, right? Hello. Are the people
Yes, sir.
getting? Okay. Pratim, Anandit, Sarthak,
Yes, sir.
Memel, Devansh,
Yes.
are the people getting?
Yes, sir.
Okay. We were distributing 10 coins to three beggars. Okay. How many of you have started going to temple or not? This is your year. Start going to temples more. Okay, anyways, I'm just kidding. Okay, so tell me, how to think about the polynomial function for distribution of three coins, I mean 10 coins to three beggars. See, what are the things can happen, okay? Write down all possible outcomes. It can happen that B1 has got 0 coins, or has got 1 coin, or has got 2 coins, or 3 coins, or up to 10 coins. Right. These are the things possible with B1. Yes or no? Tell me, everyone. Are the people getting? These are the things. I mean, these are the outcomes for B1. B1 can get either 0 coins, or 1 coin, or 2 coin, or 3 coin, or up to 10 coins. Right. Tell me. Sarthak, are you getting?
Yes, sir.
Okay. But this can happen with B2 also. So same polynomial. This can happen with B3 also. So same polynomial, whole cubed. Are you getting, Swapnil?
Yes, sir.
Okay. Now over here, since we have to distribute only 10 coins, so whose coefficient we need to find out in this polynomial? Tell me. We need to find out whose coefficient. We are distributing only 10 coins. The number of ways 10 coins can be distributed. Tell me. So whose coefficient we need to find out? First of all, we can use GP formula. It can be written as 1 minus x to the power 11 upon 1 minus x whole cubed. This will be equal to 1 minus x to the power 11 whole cubed multiplied by 1 minus x whole to the power minus 3. Tell me, whose coefficient we need to find out? If you are unable to understand, then also tell me, I'll explain. It is very important to understand this. Whose coefficient we are focusing on? We are focusing. Tell me. We want to find out whose coefficient.
X to the power 10.
x to the power 10. Are you people getting? Tell me, Sokroit, Sarthak, Rakti, Manandit, are you people getting? We are we have to find out the coefficient of x to the power 10 over here. Why coefficient of x to the power 10? Because we have only 10 coins and distributing only 10 coins. So we need to find out the number of ways, all possible ways in which x to the power 10 is formed. Right, Rakti, Anandit, Sarthak, Memel, Devang. If you didn't
Yes.
understand, you ask me. I'll explain. Tell me, Rakti, is it clear?
Yes, sir.
Okay. So we are focusing on only x to the power 10. So everyone, we can write it as 1 into 1 minus x whole to the power minus 3. Okay. Wait a minute. First of all, let us expand 1 minus x to the power 11 whole cubed. We can write it as 1 minus 3x to the power 22. Sorry. 1 minus 1 minus 3x to the power 11 plus 3x to the power 22 minus x to the power 33 into 1 minus x whole to the power minus 3. Now, first of all, tell me, do we need 3 to x to the power 11? Tell me. Whatever we don't need, I won't write. What do you think? Do we need minus 3x to the power 11 into
No,
1
sir.
minus x? We don't need it because we need coefficient of x power 10 only. So in the subsequent polynomials, in the polynomials that are going to come up, we don't, they are not required. So over here, what's the coefficient of x power 10? Coefficient of x power 10 will be equal to 3 plus 10 minus 1, C10, which will give us how much? 12C2. Are you people getting? Yes or no? And
Yes.
by using beggar's method also, you are getting the same thing. Yes or no? N plus P minus 1, CP minus 1. Tell me, anyone having any doubt, you can ask me now. Devank, do you remember? Have you understood? Yes or no?
Yes, sir.
Okay. And Sathok, Raktim, Anandit, did you people understand?
Yes, sir.
Yes.
Okay. Memel, is it clear?
Yes, sir.
Okay. Should I give another example or we can solve some problems? Tell me. I can give another example also. Achha, today only we solved one problem, right? We did one problem today. Achha, no, we didn't do any problem. Do you remember everyone this question? Find the number of ways 7-digit numbers. Find the number of ways 7-digit numbers can be chosen whose sum is 14. Right. So shall we do it using generating function C? How can we use it using how can we do it using generating functions? 7-digit numbers whose sum is 14. So since it is a 7-digit number, can I write f of x is equal to, for the first digit, x1, x2 up to x7, for the first digit, what are the values it can take? Tell me everyone. The
From
first
x
digit,
to the power 1 to x to the power 1.
exactly, x to the power 1 plus x square plus up to x to the power 9. Right, tell me. Are you people getting? Sakrit, I mean Sarthak, Rakti, Anandit, are you people
Yes.
getting?
Yes, sir.
Okay. Anandit, Memel, Devang, is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
So if it is clear, Devang, tell me what will be the next one for x2? For x2, tell me what will be the values?
Sir, x square plus x cube.
Why x square plus x cube? It cannot take 1, 2, or 0. That means you are not understanding, right? Devang,
No, sir. This one I have a problem.
tell me. If you don't understand, then ask. Again, it is a 7-digit number. right?
Yes,
What
sir.
are the possibilities for the first digit? The first digit can be what are the values it can take? From 1 to 9? At least tell me yes, no, something. X cube plus up to x to the power 9. Next. Devang, the second digit. What are the values it can take? Tell me. The second digit. Second digit, what are the values it can take? Devang, are you
Sir,
able to hear me? Yes, tell me.
yes,
I cannot hear you. Huh?
For the second digit, will it take values from 0 to 8?
0 to 8. It cannot take 9, right?
No, sir.
No, why?
Sir, because 9 is already taken in the second digit.
No, it is nothing like that. The digits can repeat now. Some of the numbers can be 14. Over here, repetition is allowed. It's not said that repetition is not allowed. We just need to find out the total number of 7-digit numbers whose sum is 14. Are you getting Devang?
Yes, sir.
Repetition of digits is allowed. Over here, nowhere it is written that without repetition. So again, tell me. And Devang, why did you say only x to the power 9? Even if it was without repetition, why did you only exclude 9? It could have been any other digit also. Are you getting how complicated the sum would become if it is without repetition?
So 10, 11, 12, these are also allowed.
Huh?
I mean, for the exponents.
For the exponents? Cannot understand. Hello, Devang, what does x to the power 3 over here represents? Tell me. Can you tell me what does x to the power 3 represents over here?
Number of values for the
No, it represents the value which x1 can take. X1 can take 3. Okay, we are only focusing on the power. We are only focusing on the power. If x1 can take 1, so I have written x. If x1 can take 2, I have written x squared. If x1 can take 3, I have written x cubed. Are you
yes,
getting?
yes, sir.
So again, now tell me, what should be the polynomial for x2? What are the, forget about the polynomial. What are the values x2 can take? Forget about the sum. You tell me what are the values x2 can take? X2 is a digit.
Yes, sir. So
What are
0
the
to 9.
possible? 0 to 9. So the polynomial will be x to the power 0 plus x to the power 1 plus x square plus up to x to the power 9. Are you getting?
Yes, sir.
You just need to think about all possibilities, some of all, I mean, total possible outcomes for each and every digit. Okay, it's
But
like a
sir,
shop.
if second digit has all the values from 0, all the possible values from 0 to 9, then what will be the third digit?
Same thing. It's a digit. For the third digit also same thing will happen. 0 to 9 only. Can it be anything else? You have anything else in your mind? Tell me.
it could be anything from 0 to 9.
Yes, it's a digit, decimal place. But Sarthak, are you getting? Tell me. Sarthak. Memel, are you getting? Tell me.
Yes, sir. So in the
So Memel,
second one, why are you doing x to the power 0 is?
because x2 can be 0. X1 cannot be 0. No? If x1 becomes 0, then
Okay,
it is a 6-8
okay,
number.
okay.
Right. Memel, are you getting?
Yes, sir.
So Memel, what is the possibilities for x3? What are the possibilities for x3? Tell me.
Sir, same possibilities.
Same. Raktim, what is the possibility for x4?
sir, x to the 0 plus x to the 7 plus x square x to the 14.
Yes, same thing. And Anandit has left. So it will be x to the power 0 plus x to the power 1 plus x square plus x to the power 9 whole to the power 6. Right, tell me. Socrates, have you understood?
Yes, sir.
Okay. So let us start. Let us simplify this polynomial. Okay, this will become x. First term is x into 1 minus x to the power 9 upon 1 minus x multiplied by 1 minus x to the power 10 upon 1 minus x whole to the power 6. Okay. So when you simplify, you are going to get x into 1 minus x to the power 9 into 1 minus x to the power 10 whole to the power 6 multiplied by 1 minus x whole to the power minus 2. Okay. Let us simplify this a little bit more. Okay. Acha, over here, we are concerned about what is the coefficient. I mean, whose coefficient? What should be the power of x? Whose coefficient we should consider? Tell me.
14, sir.
14, right? Not understand why you people are so quiet. Tell me, Sarthak, Bhakti, Anandit, if you have not understood, you can ask me again.
Sir, here in 1 minus 6 it will be minus 7.
Ah, yes, it should be minus 7. Find coefficient of x power 14. Memel, can you tell me why we need to find out the coefficient of x power 14 only? Why not something else? Memel, are you there?
Yes, sir, I'm thinking.
Thinking.
Because the, so can I say,
Tell me.
because the sum of the digits is 14.
Exactly, because the sum of the digits has to be 14. So we need to find out in how many ways 14 is formed. Are you getting, Memel?
Yes, sir, yes, sir, yes, sir.
Anandit, are you getting all of these? Yes or no?
Yes, sir.
Okay. So let us multiply. It will x into 1 minus x to the power 9 multiplied by, this is 1 minus x to the power 10 whole to the power 6. So it will be 1 minus 61 into x to the power 10 plus 62. Achha, do we need the next term? The next term will be 62 into x to the power 20. Tell me, do we need it?
No, sir.
No. So discard it. It's not required anymore. Whatever is not required, don't write it, okay? Otherwise, the expression will become very huge. Next, let us multiply. This will become x minus x to the power 10 multiplied by 1 minus 6c1 into x to the power 10 multiplied by 1 minus x whole to the power minus 7. Let us multiply x into 1, x into my, so it will be minus 6c1 into x to the power 11 minus x to the power 10. Actually, do we require x to the power 10 into x to the power 10? Do we require the multiplication of the last two?
No.
It
They
is
will be given as x to the power 20.
it's exceeding multiplied by 1 minus x whole to the power minus 7. So when you expand, this will become x into 1 minus x whole to the power minus 7 minus 6c1 into x power 11 into 1 minus x whole to the power minus 7 minus x power 10 into 1 minus x whole to the power minus 7. Tell me. Now over here, whose coefficient we need? Tell me. Over here, whose
14.
coefficient? Over here, we need the coefficient of x to the power 13.
13, yes, yes. X is already multiplied, right?
Exactly. Over here, whose coefficient we need?
X cubed.
X cubed. And over here,
X to the power 4.
x power 4. Okay. So this will become 7 plus 13 minus 1 C13 minus 6C1 into 7 plus 3 minus 1, C3, minus 4 plus 7, sorry, 7 plus 4 minus 1, C4. Okay, are we getting the same result? Tell me everyone. 19C13 minus 6C1 into 9C3 minus 10C4. Are we getting the same thing? Tell me. The one in the homework solution. Tell me. See, 19C6 minus 6 into 9C6 plus 10C6. So see, same thing everyone. Tell me, has everyone understood? Generating
Yes, sir.
functions. Tell me. Sarthak, Anandit,
Yes, sir.
Memel, Devant, is it clear properly?
Yes, sir. Now it's clear.
Okay. Okay, so I think everyone, we can keep it till now. Tomorrow, can everyone, can we start from 8:30 only? Tell me.
Yes, sir.
Yes, sir.
Yes, yes.
Okay. Devant?
Yes, sir.
Okay. And tomorrow we'll start from 8:30 only. Okay. Actually, in March, I think I'll be missing some classes in mid around 15th, okay, around 16th, 17th, okay. So I'll make up. Okay, everyone. I'll take some extra classes before
Sir, we
and
have
I'll
our
take
exam
some.
on 16th and 17th, right?
Exam will be taken. For
I
exam,
think
there's
16th
no
and
problem.
17th or 15th and 16th because 15th is a Sunday, if I'm not wrong.
No, no. 15th is not Sunday. 16th is Sunday. Let me see.
15th
Calendar.
is Sunday, sir.
15th is Sunday.
Hmm. 16th is Monday. Check it once in
Just
month of March.
okay. The month of March. Oh, I went to April. 15th is Sunday. So no problem. 15th and 16th then. Exam is on 15th and 16th. Okay. Your PNC binomial test will be taken on 16th. Okay, everyone. There will be 3 slots, whichever slot you want to give. Okay.
Sir, on 16th.
15th, 16th, and 9th also. Okay. Those who want to give it on 9th, they can give it on 9th. Okay. So there will be 3 slots,
Okay, sir.
9th, 15th, and 16th. Okay. PNC binomial test. Is it clear, Memel, Ratim?
Yes, sir.
Okay. So after 17th, I think 1 or 2 classes I'll miss. Okay. So I'll make it up before that period and after that period also. Okay. So up until March, I'll be taking 3 hour class on Tuesdays. Okay, everyone. Is it clear?
Okay,
Tell me.
sir.
Yes, sir.
Okay. Okay, so everyone, we can keep it till now.
Sir,
Thank
one
you,
thing, I
everyone.
sent you a question today, which you said, which was supposed to be solved using generating functions. Can you send me the solution using
Yes,
generating functions?
yes, yes. Wait. Let us solve it now only. You have time, right?
Yes, I have time.
Okay. So actually, Sokowitz sent me a problem using I mean, let us solve it. Okay, can you people see my screen? Okay. So let us solve that problem. Acha, now you will only be able to solve it. It's very easy now. Wait a minute. Can you see?
But sir, can I try that problem once? I have not tried using. I just said,
Yes. No problem. You try it. I'll give 1 or 2 minutes time, but I mean, we'll solve this problem today only.
okay.
Okay. Try. Tell me. X plus y plus z must be greater than 35. n must be less than or equal to 52.
Can't get it, sir.
Huh?
Can't get it, sir.
Can't get it. So first of all, you see, it's x. Wait a minute, wait. Find the number of integral. Acha, over here, x and y, x, y, and z can be any integer, right?
Positive integer, sir.
Okay. Okay, I thought it was they were digits. Okay, so I was about to use generating functions.
My
Anyways,
method is using cases like x plus y. If x, y, z are positive integers, then the sum can be 36, then 37, then 38, like this. I think using binomial coefficients can help. If you give me 1 day's time, I can try and I can see if I can get the answer.
binomial coefficient can be done. It can be done using binomial coefficients.
But
Okay,
the
it is
thing is, it will be
expressed.
lengthy. I want a shorter method for it. If it is there.
Ha, I know it is. It will be lengthy. X plus y plus z must be greater than 35. Okay, and it is less than or equal to 52. Okay, so what you do is you find out these two solutions. Okay, x plus y plus z less than or equal to 52, and x plus y plus z less than or equal to
35 and then subtract them. Greater than equal to.
35. Less
Acha,
than
no,
or equal
no
to
less
30.
than equal to. Acha, so
Yeah, sum is done only. So this is
uh,
what? Okay, it is x plus y plus z plus n is equal to 52, which is equal to 52 plus 4 minus 1, c 4 minus 1. Right?
so we can't take 0.
Positive integers, no? Oh, first we will subtract that case. Oh, no, 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 no. Only positive integers. But it can be less than or equal to 52. It can be equal to 52 also. Okay, wait. I'll give a better one. Okay. So what have we taken? X plus y plus z is less than or equal to 35. We'll find out the number of positive integral solution. Okay. So 35 minus 1. Sorry. It will be 35 x plus y plus z less than or equal to 35.
Acha, x plus y plus z plus w equal to 35, where w greater than equal to 0 and x plus y, this x y z are greater than equal to 1.
Wait a minute. Wait. I'll make some modifications. Wait. X plus y plus z plus w less than, strictly less than 35. So I can say strictly less than 34. Now it will work. Wait a minute. X plus y plus z plus. Oh no, that zero place I think we have to subtract. Oh wait a minute.
No, so can I ask something?
Tell me.
If x plus y plus z is less than equal to 35, if we consider this case, or not equal to just less than 35, then also you can simply say that this parameter w or this extra variable w is greater than equal to 0 and x, y, z are greater than equal to 1. So it's like three beggars should receive at least one coin.
Yes, you can do it. And one of them can get 0 coin.
One of them can
So
get
at
0
first,
coins.
you distribute. Or what more you can do? X plus y plus z less than or equal to 35. You find out all possible cases. Okay, n minus 1 cp minus 1, and you subtract that case when w is getting 0. Understood?
Hmm.
Okay, so you can do it now.
Yes, sir. Yes, sir. Yes, sir.
Okay, and then you subtract total minus this. I think this is a shorter way instead of taking 35, 36, 37, 38, and so on. Is it clear?
Yes, sir.
Okay. But with generating functions, what is the maximum value of x? Tell me. Maximum value of x can be equal to 52.
50. Sir, how positive integers? 50 it can be.
50, 50, right? 50. Okay. And minimum value it can be 0, 1 also.
1.
1 to 50. And same thing will happen with all of them. 1 to 50.
Sir, it would become very tricky. Because method will be there will be cases, but I think because method will be simple.
Wait a minute. X plus up to x to the power 50. There will be only one polynomial whole to the power whole cube. Over here, we need to find out the coefficient of. Okay. There will be a lot of coefficients we need to find out. We need to find out the coefficients of x to the power 36, x to the power 37, and so on. Okay. So let's see. X minus a dot 1 minus r. 1 minus x to the power how much? 50.
50.
50 terms divided by 1 minus x whole cube. So this will be equal to x cube into 1 minus x to the power 50 whole cube into 1 minus x whole to the power minus 3. Okay. So over here, this will become x cube into 1 minus 3x to the power 1 minus 3x to the power 50 plus 3x to the power 100. That is not required. Maximum will go up to 50 only. Okay. And that 150 is also not required. Into 1 minus x whole to the power minus 3. So this will basically become x cube into 1 minus x whole to the power minus 3 minus 3 x to the power 53. So the other one is becoming x to the power 53. So gone. You can understand. 3 plus 50, 50. Achha, same thing. Actually, you have to use Binomial. See, it's coming as same thing. Okay, so many coefficients will be there. X cube into 1 minus x whole to the power minus 3.
So
Now
we
over
can
here we
see,
will
okay,
find.
once you will have to calculate the coefficient of x to the power 36, then x by 37. Now, this is the
Ah,
same case
yeah,
as
same.
taking x plus y plus z equal to 36 and 37 and so on. The first thing we
Yes,
just
yes,
said
yes,
you.
yes. Yes, yes, yes.
So I'll solve it using Becker's method and I'll match the answer. If it doesn't, I'll tell you.
No, no. You solve it using this method. Okay, the one which I've shown.
Hmm.
Okay, this is shorter instead of taking so many cases. Okay. Okay, so everyone, we can keep it till now. Tomorrow again at 8:30. Okay, thank you everyone and good night.
So,
Thank you, sir. Good night.
Yeah, Devang, tell me.
when will you send the PDFs on this binomial theorem?
By tonight.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.
Good night, Anandit, Tatkil.